Alright, the last case for 10.5 is when the denominator is a repeated irreducible quadratic factor. So the denominator will be in the form ax squared plus bx plus c to the nth power, where n is an integer greater than or equal to 2. And the partial fraction decomposition will be set up as a1x plus b1 divided by ax squared plus bx plus c plus a2x plus b sub 2 divided by ax squared plus bx plus c to the second plus plus a sub n x plus b sub n divided by ax squared plus bx plus c all to the nth power. So again, similar to the repeated linear factors, is you just have to write out the number of factors to that exponent, and so you'll have the number of terms you'll have is going to equal that exponent. So if you had 4, if your power was to the 4th, it's now just a quadratic irreducible factor, so you're going to have 4 quadratics on the denominator with all the parameters up top in linear form. So we have the problem x squared minus 5x minus 2 all divided by x squared plus 4 squared. And I'm going to set up my partial fraction decomposition as ax plus b over x squared plus 4 plus cx plus d divided by x squared plus 4 to the second. And now, just to keep track of things, if this was to the third, right, we would just have to write this again, e plus ex plus f over x squared plus 4 to the 3. So it's not that case, and it's not erasing. Alright, and the other thing is, I didn't keep track of all the subscripts, I just used more letters of the alphabet. So it's really your call about how you want to approach that. I just like to keep going with the letters instead of the subscripts. And from here, the way that we're going to continue is doing what we've done before. We want all the denominators to be the same, then they'll cancel, and so we need to see which factor is missing in each of the terms, and it's only this one that's missing the x squared plus 4. So I'll multiply the top and bottom by x squared plus 4. This will make all the denominators the same, so all I have to play with is the numerator. And I'm going to write this as x squared minus 5x minus 2 equaling, go ahead and distribute this. I'm going to end up with an ax cubed plus bx squared plus 4ax and plus 4b. And then plus my cx plus d. Let's just make sure we did this multiplication right. Ax cubed, bx squared, 4ax, 4b. Okay. And I can tell I'll have a cubic, so you don't have to do it this way, but in case it does help you, I'm going to write this as 0x cubed plus my x squared minus 5x minus 2 equaling my ax cubed. There's only one bx squared, and then we have a 4a plus c times x, and then plus our 4b plus d, the constant parts. And so now when we equate the coefficients, remember, because this left side is equal to this right side, so if you look at the terms, the x cubes are going to match up, and the only way that the left side is going to equal the right side is for a to equal 0, b to equal 1, and for a plus c to equal -5, and lastly the 4b plus d to equal -2. Okay, we already have solved 2 of the letters, so 2 more to go. If a is 0, then we have c equals -5. Sweet! So we just need to find d, and b is 1, so 4 times 1 plus d is equal to -2, so d is going to equal -6. And this means we have all the parameters. When you look back up here, sometimes what ends up happening is that this linear part goes away, so we will just have 1 over x squared plus 4, and then we'll have our cx plus d. So let's erase, and then just write this in. So this is going to equal 1 over x squared plus 4 plus -5x minus 6 all over x squared plus 4 squared. So that's our answer, and I would just suggest that the key to doing these is being able to recognize which case you have and how to set up that partial fraction decomposition. And in Canvas I have just a way to test your skills to be given a rational expression, and all I want you to do is set up the partial fraction decomposition form, not to actually find the parameters. So this would be good practice to make sure that you are seeing how to set it up before you get started with homework and all. Alright, so I hope you found this helpful, and I'll see you in another video.